So, hello everyone, I am Karan.
And I'm Soham.
So, today we are going to discuss about one of the topic that is road segmentation for autonomous vehicles. So, basically, road segmentation is the process of identifying the area of an image that corresponds to the road, like which is very important for an autonomous vehicle. So, like we have done the road segmentation task first using some classical computer vision techniques like K-means algorithm and GMM algorithm, and after that we have moved to some deep learning techniques using neural networks. So to start with, we have implemented UNet model first on the Kitty dataset, and then we have also implemented it on our own dataset that we have collected in IIT Jodhpur campus and the nearby areas. So in this we have done semantic segmentation. But as we know that our vehicle also need to classify other objects on the road like barricade, animals, humans and other vehicle that are present on the road. So then we have moved our task to instance segmentation, which is done using latest YOLO V8 model. As YOLO V8 model is not trained on roads, so we have provided it with our own data set. Not only we have trained it for normal roads, but we have also taken data of Indian roads and we have also implemented it for off-road. Then we have tested it on our custom video and we will show the results further in the video. Now I will show you how we have prepared the data set to train our model. First, for this task, we have used RoboFlow website. The link will be provided in the credit section in description box below. So now we will move to this RoboFlow website. So now we will see that how we have created the mask for our data set. So first of all, you have to upload the images. So now after uploading the image, now you have to move to the next process by saving and continuing it. Then as the upload is complete, now you can assign the images. You can also divide the task with your mates if you want. Now we will go to the start annotating. Now we can see that as we move our cursor, we can see that it will start segment different things. So like as we have selected on it and we'll press enter, we will get to see these classes. We can see these classes. So I have created these classes. You can also create as many classes as you want. So like as this is road, so we will label it as road. Now we can, as this is instance segmentation task, so we can also create label for other things. Like we have created a label of animals for these cows. So you can also create labels for the remaining things, like you can create a label of this divider and all. Then after doing this, you have to go back and add this image to dataset. Now here you can split your dataset into train, validation and test. Now then we have to go to the generate section. In generate section you can do the pre-processing. So we have various pre-processing steps here. So you can select any of them and then you can also use these augmentation steps. So you can see that we have various augmentation steps. So I have added only these three steps. Then we can then generate our data set. In this we can increase the number of images. So like from one image I'm getting 12 images after augmentation and pre-processing. So now we can generate. After this you can just export this data set. Now you will get this link and this is your personal API key. So you can, this is for YOLO V8. So like you can just paste this link in your collab notebook and that this dataset will be imported there. So now we will start with first start with the classical computer vision models. So we have implemented KNN, K-means clustering and Gaussian mixture model. So like as you can see, first we have imported the necessary libraries, then we have read the image, then reshape it. Then we have applied here the K-means algorithm. So as you know that K-means is the centroid based clustering algorithm, and basically it aims to partition the data point into K cluster where each cluster is represented by its centroid. So basically the clusters are spherical in shape and of equal size. So the algorithm what it does is iteratively assigns data points to the nearest centroid and update the centroid based on the mean of the assigned point. And K-means basically produce half cluster assignment where each data point belong to a single cluster. So like that we have done here with K-means clustering. So you can see the code here. After that, we have just implemented the code of GMM also here. So basically, GMM is a probabilistic generative model that assumes that the data points are generated from a mixture of Gaussian distributions, and it models each cluster as a probability distribution with its own mean, covariance, and weights. So basically, it allows more flexibility in the model in modeling complex data distributions. It basically assigns probability to data points belonging to different clusters, allowing for softer cluster assignments. GMM estimates model parameters using expectation maximization algorithm, etc., which can be computationally more expensive than K-means. So now I am going to show you the results of both these. So you can see that I have run the model. So first it is asking for the number of clusters. So as we have a binary segmentation problem. So we are dividing it into road and non-road. So we will go for two clusters. Then first we are going for the K-means clustering algorithm. So we'll select one. Now it has initiated the K-means clustering algorithm. So you can see the results here. So it has uh, differentiated road from the other parts. And you can see the other parts have become almost yellow, and this is the black part. So now we have divided into two parts, background and foreground images. Now we will again run it for the GMM algorithm. So now again we will go for two clusters as the problem is same. Now we will go for GMM algorithm. Now the algorithm is initiated. Just wait for the results. Now you can see the results. It has also segmented the other parts from road. These are the foreground and background images. So now as you can see that the results are not so good. So like so you can see that the results are not so good. So just hold your seats and tighten your belts. Picture abhi baki hai.
Now we will see another approach to solve the semantic segmentation problem using CNN architecture. Here we are using unit architecture to solve this problem. First, I will briefly introduce you about what is unit architecture. So unit was designed for the biomedical image segmentation, but now it has since been applied to many other applications like segmentation tasks, including nature scene understanding, object detection, and image to image translation also. The unit architecture consists of basically encoder and decoder network. The encoder network performs a convolution and pooling operation to extract the feature maps from the input image. Then while a decoder network performs the upsampling and concatenation operations to reconstruct the high resolution segmentation map from the feature map. So one of the key feature of the unit is the skip connection architecture, which helps to preserve the spatial information from the encoder to the decoder. So this allows the model to make more precise segmentation predictions, especially of when the object is of complex shapes. So as we are detecting the roads we are segmenting the roads from the image. So it is very complex type. So skip connection is very useful uh, characteristic of unit, and it will give the good results. So that is what about the unit architecture. Now I will explain about the code. First, we will import the basic libraries that are required for running the model. Then we will give the path for the mask path and the image path. So first and the most important thing is the data. We have prepared the data uh, by taking the images as we have used in the YOLO V8 model also. But one more step required to give the data to the unit model, which is we need the image in PNG format. Initially, we were using the Coco dataset or JSON format. Here we need .png format. So as you can see here, we have created the mask. So white portion indicates the road and black portion indicates the non-road part. So these are the different masks for the road, and corresponding images are there in the dataset. So this took a lot of time, but now we have the mixture of Kitty dataset images and the images from IIT Jodhpur campus and nearby area. So these are the examples of the mask. Again, this is the road and this is the background of the image. Now we will import these models, import these images into our model, and we'll run the model. So first we'll split the images into training and testing data set in 80% in training and 10% for validation and 10% for training. So then we will define the function to load the model. We are loading the model using CV2 function, and the important thing is resizing, because the image may be of different size. We need to resize it to do to the same size so that there will not be error while passing it to the forward pass. Then we'll define some short function for showing the image, and the next and the most important part is the data augmentation. Here we have around 250 images of the road and their corresponding ground truth math that I've already shown to you. So we'll do some data augmentation like rotation, horizontal flip to increase the data set so that the model will not be under trained and it will give the good results. So after doing the data augmentation, we'll again do the training, validation and split test. Uh, Now we have more number of images for training the model. Here mm, we have then we'll create the dataset class. So this you can see. Then the most important thing in the PyTorch is loading the data from the data loader. We'll load the train dataset, validation dataset, and the test dataset. This now it is a unit architecture basically. So it is already available, and we are going to unit implement the unit architecture in our code to segment the road. So for segmentation tasks, we are going to use IOU loss, that is intersection over union loss. If the IOU loss is less, then we can consider the segmentation task is very good. Now we are setting the number of epochs to the 150, and I'm running the model on the GPU with learning rate of 10 to the power minus 3. So here the important thing in the Udent model is input channel is 3. Means we are giving the RGB image to the model, and model will output the single channel image, that is binary image mask. Then we are going to start the training of the model. I have already trained this model, and results you can see here. So it is epoch. I have run this model for 150 epochs, and the results are this. This is the training loss 0.011, and this is the validation loss 0.04. Now I will show you the results that are produced by the model. So as you can see here, this is the IIT Jodhpur campus, and this is the image that we have given for training. This is the second image, and in this way we have around 250 plus images, which is combination of Kitty dataset and our custom dataset. This is the corresponding ground truth mask. This is the ground truth mask for second image, and this is the image produced after the augmentation, and this is the mask after the augmentation. So this is the model loss versus number of epochs curve. As you can see here, the loss initially was very high, and as you go on increasing the epochs, the loss will go on decreasing, and then it will saturate. So our loss of the model is very less, so model has trained very well. And this is the final result of the model. So this is the original image, this is the original mask, and this is the predicted mask. So here is some noise part. So we can remove this noise by adding some more images and fine tuning the model. Now, as Karan had said earlier, the semantic segmentation part of the road is over. So now we will focus on instance segmentation part. So in the instance segmentation, we are going to detect the road, animals, trucks, and other objects that are present on the road. So what is instance segmentation? Instance segmentation is a special form of image segmentation that deals with detecting the instances of the object and drawing bounding box around the objects. So for doing the instance segmentation, we are using the YOLO model. So YOLO is nothing but you look only once model. It is an object detection algorithm
that can be extended to perform instance segmentation also. In additional, in traditional instance segmentation methods, multiple steps are involved typically, such as object detection followed by pixel-based segmentation. However, in YOLO instance segmentation, we combine both the tasks into single network, and we are enabling real-time and efficient processing using YOLO V8. So I would like to tell you about some basic network architecture. So YOLO uses the deep convolutional neural network, and as it is a backbone architecture. As its backbone architecture, the CNN processes the input image by applying the series of convolution layers, which learns the hierarchical features at different scales. So YOLO extends the object detection to instance segmentation by incorporating a secondary task within its network. So this additional task involves predicting a binary mask for each object. Like if we have animal, it will produce a mask for the animal and indicate the pixel belong to the object, and which pixel is belong to the object and which pixel do not belong to the object. The mask is typically represented by the binary image with the pixel values of 0 or 1, where 0 indicates the presence of the object. So if the animal is present in the bounding box, it will color the animal with some value of the RGB channel, and rest will not be given any color, and we will draw one bounding box around the object or instance. So now I will explain you about the code. So first we'll check the GPU is available or not. If the GPU is not available to you, then it may require the larger time to process the model. So here we'll import, the first important thing is from Ultralytics library, we'll import the YOLO V8 model. Then, as the current said earlier, we have already prepared the data set of the road, which contains the Indian road. We have also taken the images at the night in the road, so that if the vehicle is traveling in the night, we can segment the road in low light conditions also. And we have the good images also, which are of the highway and the city. And some images contains the animal, so we can detect anything that can come onto the road and which may cause any danger to the vehicle. So in this way, we have created the dataset. Now we'll import dataset here by the command that is given by the RoboFlow. So once the dataset is imported successfully, we will go for the custom training. So here we have already cloned the Git repository, or we have already installed the YOLO V8 model. So we'll select the segmentation model from YOLO V8, which is useful for doing the instance segmentation. Then we will train the YOLO V8M model. So there are different models of V8, that is YOLO V8X, YOLO V8M, YOLO V8S. So S stands for small. So small model will give the results in shorter time, but its accuracy will be less. Means it will not be able to detect and draw the bounding box very correctly, but it will give very fast results. So we are using YOLO V8M model, which is the compromise between the speed and the accuracy. Here we will set the number of epochs as 10. You can change the number of epochs and learning rates as per your requirements and fine tune your model. So I have already run the model. Now I will directly show you the results. So these are the results produced by the YOLO V8 model. These are the different classes that we have defined in the dataset, that are animal, auto, barricades, and so on. The most important class is the road, and as you can see here, it is able to segment the road with MAP 1595 as 0.88. Means it is able to, it is around 88%, and which is considered as a good value. Also MAP 50 value is also 0.96 for the road, which is also good. So we have run this model for different epochs and different learning rates. So this was the best result that we get till here. Now we will see the different types of performance that model has given to us. So this is the performance metric of the graph. As you can see, the training loss is going to decrease as the number of epochs are increasing. Segmentation loss also decreases. And there are matrices, that is MAP 50 and MAP 5095. So as the number of epoch go on increasing, mean absolute precision is increasing at 50 IOU. Mean absolute precision at 50 to 95 IOU is also increasing. Mean average precision. So here are the graphs of the training level training that we have already seen. So now we'll see the validation set. So while running the model, so you can see the here. So this is the road with 90% probability. This is the animal with 100% probability. So this image is taken in the night, and it is also able to segment this image very perfectly. These are some images from the road, and these are the images from our IIT Jodhpur college. As you can see here, it has instanced the tractor also. So now we'll go for custom model training. So I have already done it, and inference on the custom model. I have given 40 images for the testing, and you can see here. So this is the road and the tree. It is able to separate correctly. And the most important part of is testing on off-road conditions. So here you can see it is a off-road condition, means there is no proper tar road available. Still the model is able to detect the road very perfectly. That was our aim of the model, so that vehicle can move in any terrain, in off-road situation, in low light situation also. So here are the results from low light conditions that are also good. Here are the again results from the off-road. As you can see, there is no road clearly seen to the human eyes also, but model is able to detect the road with probability of 97%. Now these are some more results from the model. So if you want to check anything from the internet, then just download any image and you can segment it and do the instant segmentation for it. So that's it about the YOLO weight.
Now we will going to discuss about the next method used for the instant segmentation task. This is done by using the Detectron 2 model. This is basically developed by the Meta AI in around year 2018 for the task of object detection and instant segmentation. So basically this Detectron 2 model is typically a convolutional neural network responsible for extracting high level features from input image, and it supports various backbone architectures like ResNet, ResNext, DenseNet, etc., which are pre-trained on large-scale image classification datasets like ImageNet. So basically, what it does is it has two parts: region classification and bounding box regression. So Detectron 2 performs region classification and bounding box regression by predicting the probability of each proposed region belonging to different object class, while the regression network refines the coordinate of the bounding boxes to tightly fit the objects. Then one of the good approach used by it is a feature pyramid network. It is basically used to address the challenge of detecting different objects at different scales. So basically basically it creates a feature pyramid by fusing features from multiple levels of backbone network. The feature pyramid allows the model to detect objects of varying sizes and improve the localization accuracy. So it basically uses different type of architecture like faster RCNN, fast RCNN, or mask RCNN, etc. So now I am going to discuss the code with you. So first of all, we have used the GPU. Then we have just installed the Detectron 2 and its dependencies from Git. After doing that, we have imported the other necessary libraries like Torch and all. After doing that, we have run the pre-trained model that is already trained on different classification data sets. So this is just a sample image of that data set, and now it has shown person, horse, and all different things like umbrella, and these are the probabilities which they are predicted. Now in this we have used the Coco format data set. Now as Soham has already discussed, we have made our own custom data set. So to run Detectron 2, we have used the data set in Coco format form. So then this is from the RoboFlow from where we have made a data set. So we have just imported that data set. After that we have we visualize one of the image. So this is one of the image from the data set we have collected. Then basically we have trained the model. So like these are the different parameters like learning rate and the maximum iteration epochs. So basically you can fine tune these to get better results according to your task. So now this is the training part. So basically the training of the model is done, and then this is the main part, that is the evaluation part. So like then we have evaluated our model on some of the test images, and test images are also provided by us, and these are from our IIT Jodhpur campus. So like you can see the results on these images. So this is basically a off-road area. So you can see that In spite of being a off-road, it has predicted with 100% probability. So that's it from this model.
Now we are at the end of the video. I would like to conclude the session by comparing the different models. Out of all algorithms, YOLO V8 has performed very well in every situation. As we have collected the images from Indian road, off-road, and low light conditions, it was able to detect every road and every object very well. And you can see the video here. It is detecting animal, scooter, person, truck, pole, divider also. It is also able to detect the barricade also. Now I would like to walk you through the GitHub profile. So this is the GitHub profile that is created by both. The first file is the detectron 2 as Karan mentioned earlier about it. Second is the KNN and JMM algorithm. Instance segmentation model is based on the YOLO V8. And last but not the least is unit architecture that is useful for semantic segmentation. This is about introduction of semantic and instance segmentation. This GIF shows us the how to create the custom dataset for semantic segmentation, and this is the result produced by YOLO V8 algorithm that is on Indian road, off-road, and the low light condition. These are the performance output of the YOLO V8. Also in the unit architecture, we were able to achieve very low loss that is about 0.03, and in the YOLO gate algorithm, we were able to achieve the very high mean absolute average precision value that is about 90%. So if you have any comments, then reach out to us at the mentioned Gmail. And if you like the video, then please like and comment the video. Thank you.
Thank you.